Hello, everybody, and welcome back to Glow Your Own. This is session 6, 2024. We've got Sarah and Sophie back, and I'm Dane. And today we're going to be adding a little bit of movement to our kinetic lanterns, a robotic effect. So we started off with a single LED, we then added a sequence of flashing, we put a button in, we put a photoresistor to introduce remote control and sensitivity to our little tabletop devices. We were a bit crafty last time, and today is the final step to add some movement. So, Sophie, are you ready to help people do their coding to get some kinetic lanterns working?
I am, and I'm very excited about it. I do love making things move, even though I then fall over them. But it's worth it because it's always really satisfying. So yes, today we are going to use this type of motor called a servo motor to make our wonderful creations move. So you might remember that last time Vicky had helped me to make a shooting star. So I'm gonna code a motor so that I can move my shooting star. So just like normal, we're going to go onto Tinkercad first. We'll build the circuit and we'll do the coding on Tinkercad, check that all works, and then we will uh, make it in real life with our real servo motors and circuits. So I'm just going to share my screen. So you can see my Tinkercad screen, everyone? Yeah. That's good. All right, so I'm going to join with nickname, and my nickname is GYO5000. Just like normal, if you've forgotten your nickname, just pop something in the chat, and Dane or Sarah will be able um, to help you. Now, you can use one of the circuits that we have done before. So once you've logged in, you can see all of the circuits that you've done before. I'm going to create a new circuit just so that just with our servo motor, just so that we can focus in on it and not get confused with any of the other wires or things. But you can absolutely just add on to your existing circuit if you would like, or you can make a new circuit. It's entirely up to you. So I'm going to create a circuit, which is up here, and then circuits. And then I'm going to wait for a bit because Tinkercad always takes a little while to get to that point. All right. First thing I'm going to do is I'm going to change the name of my circuit so that I remember what I'm doing on it. So I'm going to call it GYO Servo because that's what we're going to be doing today. And just like all of the other times, our first two components, we're going to bring an Arduino out and a breadboard out. So I'll pull my Arduino out like this, and I'll pull my breadboard over here. So far, that's exactly the same as we've done before. And like I said, you can just use one of your existing circuits and just add on a servo motor if you would like. I'm just going to do the servo motor so that you can see it really clearly. Right, now you can see over here on oh, I forgot to put a left and a right sign on my computer. Over here, right, we've got all of our components. And if you go down here to just below the Arduino, you can see the different types of motors. And they're all used for different things. We use them for different things here on site. But we are going to use a type of motor called a servo motor. So a micro servo. So I'm going to click that. And I'm going to pull it over so that it sits next to the Arduino, because actually the servo motor is a little bit big and it doesn't sit directly on the breadboard, but we're going to wire it up through the breadboard to make life easy for ourselves. Now, you can see on the servo motor that there are three little pins or three holes here. And the really nice and helpful thing about Tinkercad is all of them are labeled. So if you hover over it, you can see I'm hovering over it, the one on the left, and it says ground. The one in the middle says power, and the one on the right says signal. And so that's a really good clue as to what we're going to plug into all of these different, into these three different holes. So firstly, we're going to connect to the power. So I'm going to go, no, not firstly, we're going to connect to the ground. So I'm going to go from the ground, 1, up here, and then across to the blue line on my breadboard. Okay, so it goes from the ground pin on the servo motor to the blue line on the breadboard, and then from the blue line on the breadboard, I'm going to draw another wire that goes to the ground on the Arduino. Now, for the circuit that I'm making, I could actually just ignore the Arduino, ignore the breadboard and go directly from the servo motor to the ground. But we're going to do it through the breadboard so that if you want to be adding on to your circuits with the lights and things, which you totally should in the end, then it's really easy for you to see which bits are going where. Okay, so wire 1 is done. Now, you'll remember that I talked before about the colors of the wire really helping. So I'm going to change the colors of the wire to brown so that I can remember that that is going to the ground. So that one's brown, and then that one's brown too. Oh, brown too. So I know I can trace that really easily. All right. Next step is going to be the power one, which is in the middle. So I'll just give you a minute just to make sure you've all got that first of wires in there. If you were building on one of your previous circuits, you won't have had to make to include this wire because we already will have a wire going from the blue line on the circuit on the breadboard. Sorry, words are really hard today. To the ground on the Arduino. Right. So next step, we're going to go from the power, do the power. So we're going to go from the power line here, all the way up here to the red line on my breadboard. And I'm going to change that to a red wire. So I know that it's power. Power is going from there. So the power goes from here to the red line on the breadboard. And then I'm going to go from the red line on the breadboard to the power on the Arduino, which is all the way down here. The one that says 5V or 5 volts. So there we go. So we've got those 2 wires as well. I'm just going to move that up a little bit and move it in so we can see a little bit more clearly. All right. Okay, so far, everyone? Give me a thumbs up or a single emoji in the chat if you're doing okay. Brilliant. Looks good. Oh, and I enjoy that some of your Tinkercad's very tidy. I like nice, neat wires, especially on my Tinkercad. I don't have the patience to do it in real life, but on Tinkercad makes a lot of difference. All right, just one more wire, everybody, to go. You're all doing splendidly. Just one more wire before to complete our circuit on Tinkercad, and that is the one called the signal. Now, I can't remember if we've used the word signal before in Glow Your Own, but it's just the word that we often use when we're sending a message out or sending a message to something. It's the signal saying turn on or turn off or move around or whatever it happens to be. So just like we did with our LEDs, we're going to connect our signal to one of our digital pins up here at the top. So I'm going to go here. I'm going to go all the way around so that I don't have too many wires crossing them. But it's going to go all the way up here. And I'm going to go, let's go to pin 2, shall we? Then I'm going to tweak it. And then finally, I'm going to change the color of my wire to green because I know that that is, I'm sending a message out, a signal out saying, this is what I want you to do, servo motor. You should do this. All right, so that is our circuit. And now we are ready for the coding bit. Now, the coding bit is fun because we get to introduce a new thing that we haven't done before that it makes coding so much easier and so much more helpful for all of the science that we do at my lab here and all around the world, and that makes your phones work and everything. So I'm just going to move that over to the side a bit, and then we're going to go to the code. Now, just like always, remember, we are recording this. And so if you miss a step or anything, we've got the troubleshooting at the end, but there's also going to be the video. So you can always watch the video and every step. So I've pulled my code out by clicking on this link. I'm sorry, I've just had a message saying my internet connection is unstable. I am on site at a big scientific lab, so I'm very sorry that my internet connection is unstable, but hopefully it will be fine. Dane can easily take over if he needs to. All right. But I think I'm fine for now, Dane.
Good.
Right. So we are going to get rid of the normal code that Tinkercad says, oh, would you like to do this? Would you really? Would you? We don't want to do that. We never want to do that, Tinkercad. So I'm going to put that in the bin down here at the bottom and get started on our new bit of code. And the fun thing that we are going to do is use this kind of pinky one called variables. And variables are really important. They're remember this number, okay? Do you remember this number? I'm calling this number Bill or whatever. You have to remember this number, and then you can change it however you want, but the computer will always remember the last number you told it. And what we're going to use that for is to tell the servo motor how much we want it to rotate. Because the thing about servo motors is they rotate a certain number of degrees. They rotate to a particular angle, and they'll tick around like this. And then I can't go any further because my wrist doesn't bend any more than that, but you get the idea. So we are going to set two different variables to start with. So I'm going to click on this one, which says variables, and then you get to create your own variable. So just click on that, and it asks you for the variable name. It will just remember it forever and ever, and that's fine. But when you're reading code, and especially when you're working in big teams like we normally do when we're writing code, it's really sensible and to call it something that you're going to remember immediately what that variable means. Just like we named this circuit GYO servo because it's the circuit about Glow Your Own and the servo motor. It's sensible to name it something that is really easy for anyone to understand what we mean by this. So the first variable we're going to create is I'm going to call angle, because it's the angle that we're going to send out to the servo motor and say, servo motor, I want you to be at 15 degrees or whatever. Okay, so we type in our variable name, we click OK, and then it comes up with some blocks. You can either set the angle, or you can change the angle by a certain number. So we're going to pull that out to start with. Set angle to 0 degrees. So that's straight up like that. 0 degrees is straight up. A lot of you will have done degrees at school, but it's just a measure of how far around you are in a circle. Okay, now what we want to do is in Tinkercad, it's a repeat loop. Now, we've done forever loops before, so we want something to happen forever and ever and ever. And this is kind of a cheating forever loop. So if you go to control, we're going to say repeat. But instead of saying repeat a number of times, you want to pick the one that says repeat while, so that you can click it onto this set angle. All right, but actually we do want it to happen forever. So we're going to set that is always going to be true. So
Sophie, would you mind just repeating that bit? You sort of froze halfway through a sentence.
Oh,
Sorry.
I'm sorry, everybody. So what we want to, now that we've set our angle, we want to send lots of messages to our servo motor that tells it what angle we want it to be at. But actually, we want to send those messages forever. So we want to send the messages forever. But if you look at the forever loop that Tinkercad gives us, it's not going to click onto underneath this set angle, is it? So we have to cheat a little bit. So we get the loop that says repeat while, and we're going to, and that will repeat while something is true. And it could be something like repeat while it's light or repeat while it's dark. So you use it a bit like an if loop sometimes, but we're going to set what we call a condition, something in here that is always going to be true. So everything in this loop is going to keep happening and happening. So we're going to do repeat while, and then let's go to some maths and get the nice hexagon that clicks in, just like with the if loops that we've used before. But instead of, and we're going to repeat while 1 is equal to 1. So 1 is always equal to 1. So all of the instructions that we put in here, they're going to keep happening forever and ever and ever. So it's like a forever loop. It's just a different, it's just a bit of a cheat one so that we can include the set angle as well. All right, how's that going? Have you all got that bit of code? Do a reaction, a thumbs up. It's easiest if you do a reaction with the in the thing so that I can see what you're doing. Brilliant. Got some lovely thumbs up. Good job, everyone. Oh, a tick and a thumbs up. I like it. Fantastic. You're doing really well. So don't worry if you're not quite ready for the next step. This is all being recorded, so you can always watch the video. It's also all on the worksheet that Dane sent out earlier this afternoon. And so you can always follow along across from the worksheet as well. Okay. All right. So I think we're all, you're all doing brilliantly. So what we want to do is we are going to send a message out, and you'll remember that that was when we did it with the LEDs, when we turned our lights on, we used the output block. So it's in the same thing in here where you can set these LEDs, but there's a special command that says rotate servo on pin to a degree, to a value. And that's the one that we want. So make sure it says rotate servo and pop that in there. Okay. Now, my servo motor is connected to pin 2. So I need to change that number to pin 2. And then the angle that I want it to set to, so I could just say set it to 15 degrees, set it to whatever number of degrees that I wanted to set it to. But we want it to keep moving. So we're going to keep changing that angle. So I'm going to go back to this variables thing. And then you see that there's this little round circle that says angle. That's the variable. And I can pop it in there. Okay. So it's going to send a command out through pin 2 to the servo motor and say, servo motor, please can you be at this angle? Whatever that angle is, that's the angle I want you to be at. So if we ran this code now, it would be really boring because it would be saying, well, set the angle 0, and I want you to rotate the angle to 0. And I say, well, that's what it is. That's not very exciting. What we want to do is we want to change it. Now, you can see that Tinkercad has this lovely option here that says change angle by a certain number. So I'm going to pull that one out, put it underneath my rotate. And let's say we'll rotate the angle by, say, 15. Okay, that's about just a little bit. It's not too big, but it's not, but you should be able to see it if it moves by 15 degrees. So we want to change the angle by 15 degrees. So it would say, so let's walk through the code. That's always a helpful thing to check that it's doing what you think it should be doing. The angle is 0. Okay. Rotate the servo to 0. Fine. Then change angle by 15. So angle is now 15. Then it goes back to the start of the loop and says rotate in 2 to angle, which is now 15. So rotate it to 15 degrees. Then change it by another 15 degrees and by another and by another. And we'll see how it works. All right. So are you all ready to try this with me? Ready to try? Fantastic. Doing well, everybody. Great. So, just like always, we are going to check our code by starting our simulation. I'm going to cross my fingers because it's a while since I've made a servo motor code. I might have done it wrong and Sarah might just be going, Sophie, this isn't going to work. But we'll see how we're doing. So I'm going to start the simulation. What I hope I'll see is this servo motor, this blade, like that looks like a helicopter. I hope I'll see that start to move around. So start simulation, thinking about it. Oh, and it's moving backwards and forwards, which is really good. But it's not doing quite what I was expecting it to do. It's just juddering around. And maybe what that is because it's not, I told it to move, but then I didn't tell it to wait. So computers can send instructions much faster than a servo motor can respond to them often. So it's normally a good idea to put a bit of a delay in there. So I'm going to add another code in here that says wait. So you remember we did this when we were doing flashing lights, and if we didn't put that wait in, it was sending the signals, but the light couldn't respond that quickly. So I'm going to change it to 0.5 seconds, say, just because I feel like it. And then I'm going to see what happens again. So let's see if this works. Thinking about it. All right, and now it is moving like that, and it moves all the way around, which is exactly what I was hoping it would do. So the thing about servo motors that I can't remember if I said or not is servo motors are really good at moving half a circle, but they don't move the whole way around the circle. They just move half a circle and then they can move back and then forwards and then back. That's how these servo motors work. So looks like we've got something that is going to work brilliantly. If we have time at the end, we can tweak our code so that it will move forwards and then move backwards and then move forwards and then move backwards. But I think that maybe we'll build our real circuit to start with, so that we've all got that working, and then maybe we'll come back to it at the end to see how you can do that. Or you can have a think about how you might want to change the angle, because we want to go up by 15 degrees and then we want to go back down to less time. Right. Okay, so I can see that a few of the a few of you are there, which is fantastic, but I think that quite a few of you have got it moving just like mine. So it moves half a circle, follow, 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 and down. and then it stops. Okay. Are there any questions before, Sarah, that you think it would be helpful for us to talk about before we go to building
Yeah,
the real
someone
one?
has just asked an interesting question. They asked whether we could display the variable so that we can see what's going on. So I don't know if you remember from one of the previous sessions, we used the serial monitor, but maybe Sophie could put that bit on the screen so you can watch what happens as the variable changes. Might help explain what's going on a little bit.
Yes, that is a fantastic idea. So if you go to output here, then you'll remember that you can print a number to screen, and that's really helpful when you're trying to understand what's happening or to debug. So if we it's called print to serial monitor. I'm not really sure why it's called print to serial monitor, but it is. So we're going to pop that in here, and let's put it underneath this. Actually, no. Let's put it at the beginning before it moves. So this will print to the serial monitor, which on Tinkercad you can see down here at the bottom, the phrase "Hello World," which is nice, but it's not what what we're interested in. We want to know what that angle is. So what instruction we're sending to the servo motor. So you go to variables, and then you can pull the angle out here like that. And so it should print that angle to the serial monitor, which if you click on it down at the bottom, it will say serial monitor, and then it will send it up here. All right, so let's see what it does when we do that. So we're going to start the simulation. Thinking about it. All right, so it goes 0, 15, 30, 45. You can see the number changing down here at the bottom, but when it got to 180, then it stopped, because that's what they do. They can go from 0 degrees, which is up here, to 180 degrees, which is down here. But they don't like going all the way around. That's one of the limitations of servo motors in a way, but actually it's really helpful for us, because if, for instance, like me, you wanted to attach your servo motor to your lovely star, that's great, but you'll see my star has lots of wires that connect it up, and if it just kept turning round and round and round forever, those wires would get horribly tangled and would get pulled out of the LEDs. And so it's actually really helpful that our servo motor just goes from the top to the bottom. Okay. Does everybody else's do the same? Can you see the angle changing by 15 degrees? Oh. So if you do have, if it's not quite working, then if you put your Glow Your Own nickname in the chat, then Sarah and Dane can have a look at your circuit and look at your code. They can give you a bit of a hint about what might be a good thing to try next. So don't worry, pop your nickname in the chat if it's not quite working. And just as always, don't worry if it's not quite working. Like I said, mine didn't work perfectly the first time, because I haven't done this for quite a few months actually. You just have to persevere. This is all on the recording, so you can watch the recording, pause us, so you make sure every step is the same. Don't pause when my video froze, because that's just going to look weird for me. And it's also all on the worksheet that Dane sent out before.
Right. I noticed, so I put my, originally I put my angle to, set angle to 0 degrees, and I accidentally put inside my repeat loop, I also put another set angle rather than change angle. So sometimes tiny little sort of errors like that can be difficult to spot. But just making sure if something's not working, compare it exactly to what's in the worksheet. And that's a really good way of just copying what Sophie's doing, because it is really tricky. But if you just copy exactly what Sophie's doing, you'll then maybe understand why it's happening. It might be that you don't get it right away, but it might be that if you do it a few times and you tinker with it, you'll understand what makes things work. So don't worry if you don't feel like you're being super creative, but just copy what Sophie's doing. It is really hard, this one. So be kind to yourself on this.
Always be kind to yourself.
Mhm.
Absolutely. Another thing that I find can be quite helpful when you're checking code is to read your code out loud to yourself. And that might be quite tricky at the moment because I'm babbling at you about all of the different things. But it does help because you say, right, set angle to 0. Okay, that's what I want to do to start with. Yes. And then repeat while 1 equals 1. And if you read it out loud, then sometimes it makes the bugs. That's what they're called when there's something not quite right in your code, a bug. Reading it out loud sometimes makes it easier to spot where those bugs are. They're called bugs because in the first computers, there were errors caused by actual little bugs creeping inside and shorting out the circuits and everything. Oh, I can see some people have done it. That's fantastic. But and thank you for putting your things in the chat. All right, so what we're going to do now is we're going to start to build the real circuit using our servo motors. So you can see, actually, you know what, I'm going to take out my blurriness for a second so that you can see. This is my office, everyone. You can see exactly what the servo motor looks like. It might just look like this, so without the little thing on top, because this is just like the kind of blades of a helicopter, and that has different bits that you can put on it. So there's one, and here's another one. So this is the one I want to attach to my star, but just for now, I'm going to attach the 4 on so that you can see it quite clearly what's happening. Like that. So it just clips in together. And you can see that there are 3 wires that come out of it. And then it leads into a little, let's see, are you going to focus? No, it's not going to focus. It leads into a little white block, which has 3 little holes in it. Okay. Let's put this back on and we'll switch back to the Arduino cam in just a second. I just want to leave this code in the circuit up just for a little bit longer. So I hope you've all found your servo motor. Now you'll see that on most servo motors, it's not on all of them, unfortunately, but most servo motors, the 3 wires are 3 different colors. So mine are black and red and white. And so you remember we were talking about the colors of the wires meaning different things. So on mine, the black is the earth, it's the ground. The red is the power, and then the white is the signal. Okay, so you remember these 3 different things. So this is the ground, this one's the power, and then this one is the signal. All right, so I'm going to plug mine in to that, and I've got 3 different wires here to plug in. Right, Sarah, do you think that I can stop sharing my screen for a minute so that we can see the real Arduino, or would it be helpful to leave the screen up for a bit?
I think you're probably okay to close it for now. If you've posted your nickname in the chat because you're having some problems, I am working my way through. It's taken me a while to get through. So if I haven't helped you yet, do post your nickname again. And I'll have a look while you're listening to Sophie's next section.
Yeah, thank you, Sarah. And remember, this is all being recorded, so you can always pause us, get to the right point, and then carry on. All right, so I'm going to stop my share and turn the Arduino cam on. And then I'm going to find the Arduino cam. Here we go. to spotlight for everybody. All right, let's just move it over here a bit so that you can see. So here is my servo motor. You can see in all its glory. And then here is the little set of plugs that you were going to put our wires into. Okay, with the 3 little holes at the top. So I'm going to take a black wire. I'm going to lose my black wire. I'm going to take a black wire and plug it into the hole that the black wire goes to, which is here. All right. Then I'm going to take a red wire and plug it into the hole that the red wire goes to, which is there. And then I'm going to take a green wire. Oh, you can't see. There we go. And plug it into the wire that the white one goes to. So the black is going to be my ground. The red is going to be power. And the green is going to be that signal, that instruction. Yay, I just saw a yay flash up in the chat. So good job, whoever did that, got that working. All right, so we've got our 3 different wires and we're going to plug them in. So we could plug them into the breadboard, like on the circuit, or you can plug them directly into the Arduino. I'm going to plug mine into the breadboard so that it's the same as as yours will be in as the same as on the circuit. So I've got my power, and that went to the red line on the breadboard. You can see my red wire going to the red line. And I've got my ground, the black wire, going to the blue or black line on your breadboard here. All right. So you can see that that's connected there. And then I'm going to connect it up to my Arduino. Let's see if I can push this forward a little bit so you can also see my Arduino. Yeah, there you go. So I want to connect my wire from my servo motor to pin number 2, because that's the pin that is on my Arduino. Yeah, so you can see that that is connected to pin number 2. And then I just need to connect the ground on my Arduino to the blue line on, sorry, I picked up entirely the wrong wire then. The ground on my Arduino here to the blue line on my breadboard. And the power, the 5V one on my Arduino to the red line on my breadboard. There you go. Now that looks really messy. That's why I like doing it on Tinkercad first, so I can be sure that all of my wires are going to the right place. But it's exactly the same as on Tinkercad. And you can see, I'm going to pick this up just for a minute so that we can trace the wires. So, and let's unplug. Sorry, that's looking a bit. I don't want to make you all seasick when I move around. So here I've got this red wire that traces from the 5 volts on the Arduino all the way over here to the 5 volts, to the power line, to the red line on the breadboard, just there. And then the red line on the breadboard also goes from this wire all the way along to my servo motor, which I've knocked over already. Good job, Safe. Like that. And then I've got the green wire, which is going from the servo motor, the signal, all the way to the Arduino to pin 2. And then the black wire from the servo motor goes all the way to the breadboard in a very loopy way, to the black line on, or the blue line on the breadboard, and then that also goes from the blue line all the way to the ground on my Arduino. So my circuit is done. let's stop that and unspotlight it. All right, we are so nearly there, everybody. We are so nearly there. Looking good. All right, so you'll know the next bit because it's the bit where most errors come up, which is us sending the code to our Arduino. All right, so let's just share my screen again so we can do that bit together. There we go. So here's my Tinkercad back. We're going to open this up and we're going to go to the Arduino app. Arduino.app and Dane, if you could pop the link in the chat just in case somebody's forgotten it, that would be brilliant. Thank you. So we get to this Arduino app. Helpfully, Zoom is covering all of the important things for me, so I'm just going to move that. And we're going to click over to code. We're going to create a new project. I'm going to call it GYO Servo. Create. This is exactly the same as before. And just like Tinkercad, it's like, oh, I really want you to blink your LED. That's not what we want to do today. So I'm going to delete that all. And then I'm going to copy the code from my Tinkercad to the Arduino app. So I'm going to go here, back to Tinkercad. I'll switch from blocks to blocks plus text. And then you can see the C code here. It's a bit longer than it has been before in some of the cases. But I'm going to copy it all. You can see that I'm making sure that every single bit of my code is copied, because if even a tiny little bit, even if just this weird curly bracket thing is missed off, the Arduino will be like, I don't understand what you're telling me. This is too confusing for me. I'm going to copy that, and then I'm going to pop it into Arduino. All right. Now, we do have one extra thing that we've got to do with this particular code. Now, servo motors are a bit more complicated than LEDs or the buttons that we've been using before. And so it needs a few more instructions. The Arduino needs a few more instructions to understand really what we're talking about. But the great thing with lots of code is that loads of people do this all around the world. And so they've already written a whole set of instructions that we can just be like, oh, can you make sure that the servo can talk to the Arduino, please? And they're called libraries because libraries are wonderful, wonderful things and wonderful places where you can get all of the information. So if you all follow along with me, what we need to do, and this is on the worksheet that you've all been sent, so don't worry if you miss a step. You click on libraries here. Here are all of these different things that people have written that are like, oh, you could do loads of different things. If you look down here, there's actually 6,606 different libraries at the moment, and they'll do all kinds of different things, like just helping translate between the Arduino and all of the different components that you can put on it. But we want to do one that is called servo. So if you click up here in the top left, top right, and then write the word servo, you'll see right at the top, this lovely person called Michael has already written a kind of translation, a way for the Arduino to translate what it's saying to the servo motor. So all you need to do is click on that one, and then over here on the right hand side, you click the word add to project. So that means that the computer will send all of that kind of translation to the Arduino just so it knows how to talk to our servo motor. Then we go back to code and we do the same thing, except I can't. Oh, does anybody want to guess why I can't compile and upload? That's because I haven't plugged it in. Okay, so next step, plug your Arduino in. Here we go. So I'm plugging that in just like normal. Oh, sorry. My wire is a little bit short for my desk at work. So just have to move a few things around. All right, so my Arduino is now plugged in. My little light is on, so I know it's plugged in. I'm going to go down to the bottom and select device, just like we've done every other time we've sent the thing to the code. And look up here. So you remember, I complain about this a lot. I'm sorry. It's just really silly that it doesn't call it Arduino always, and it calls it random different things. But the one that sometimes yours will say Arduino, mine says USB serial device, COM19. So I'm going to click on that and click connect. When I do that, my Arduino makes a little flicker going, oh yes, I've connected. That's good. That's good. And then I'm going to compile and upload, which is send my code off to the computer. All right. Now, I know I did those libraries a little bit quickly. So are there any questions about libraries? Would it be helpful if I showed people that again, do you think? Or are you all happy for us to try and send the code to the Arduino? I can see someone's worked and it freaked them out, which is, I'm sorry I freaked it out, but I'm so glad it worked. That's marvelous. All right, well, if you're trying, I'm going to try. So let's see. I'm going to click this one here. It's thinking about it. It's thinking really hard for me. It's uploading the code, sending that on, and it's done. Oh my gosh. It made me jump too. But you can see it moves. So you can see it moving in front of me. All right. And it moves around and around and around. It's very cool. I'm going to show you one little trick with the Arduino cam just quickly so that you can see it moving there. Moving, doing just what we want to do. But then, like I said, it stops at that certain point. It stops at that point, and that's because it's got as far as it will go. So what we want to do is reset, and we will be able to code. We can code it, and there's instructions in the worksheet. But if you just want to do that, you'll see that there's this little button here on the Arduino, right next to the wire, and that resets it. So it basically says, Arduino, just take a minute, think about it, and then start again. So if I press that, click, you'll see that my Arduino, the servo stops and then goes back to the end, which is what we wanted what we thought it would do. And then, so I hope that you've all got yours working. I hope it didn't make you jump like it did at me and at least one other person, even though I literally knew what was going to happen. So the way that you can then attach it to your creation. So you take your little blade, and I am just going to stick my little blade to the back of my star, just with some sellotape. Yeah. Like this. I'm going to try really hard not to break all of the wires while I do it. Okay. Then I can take off the one that the blade that I had and pop it on. So you can see now it is connected to my wire, to my thing, and You can see now I have a real moving shooting star. You have all done so brilliantly. I'm so impressed. We did that so quickly, everybody. I'm just going to unplug my motor so that it stops moving. I'm so impressed. You've all persevered. You've all done absolutely fantastically. And I hope you have some beautiful moving creations. Dane, it looks like you've got something that's moving and flashing. Oh, you're muted, but we can totally see it moving.
Okay, so very happy that this one's working. So I've managed to put in a little flashing. Oh dear! Now it's got to the end and it stopped. So I'm just going to unplug it.
Remember, you can just press the little button on your Arduino and it'll go back to the start.
Oh, thank you. Thank you for that. That's good. So it's the little reset button. Is that right?
Yep, little reset button.
So mine will go for 180 degrees. I've managed to attach it to a little cocktail stick, and I sellotape that to my propeller, my little helicopter blade that Sophie's attached her star to. And all I've done is I've put a set pin to high, wait a second, set pin to low, wait 0.2 of a second. Oh, and it's done that thing. So I'm just going to just for completeness, I'm going to unplug it quickly. I've already got an egg box with a hole in it.
Here's one I made earlier.
Here's one I've sort of almost made earlier. So I'm just going to pop that into there, plug this all back in, and then you've got your little, so you get the ideas. You can have a little flashing thing on your egg box or whatever box you've got design. So you can now have a moving, flashing, and obviously I haven't got the light dependent resistor on today, but you can even make it sensitive to the light in your room. So hopefully you've now got a bunch of different new skills that can get you coding and building what is essentially a very basic robot. So you're now all robotics engineers, so that's pretty cool. So in 6 weeks you've gone from understanding what an LED is, putting buttons together, coding things, putting light sensitive resistors, you've been putting a motor together. So if you've managed to kind of stay the course, really well done. It's hard work, and we've had lots of trouble along the way, and if you stay behind, we'll be doing the troubleshooting. If you're watching this on demand, please have another look at the worksheets and just really be careful to check your code against the diagrams that are in the worksheets. The tiniest of error will make the whole thing just not work, which is super frustrating, but that's just how computers are. So you just need to be really careful. And as Sophie was saying, when you're learning to read, it might be that you read books by speaking them out loud. It's completely okay to read out code out loud to make sure that you've got it all understood. But if you've managed to kind of, and I got this working just before, and it wasn't working, and I had to fiddle around and unplug things. And as I said before, I managed to put my code in wrong, saying set and change, and I even put the pins in the wrong way around, and I connected my ground to the voltage, and it just wasn't working. And I thought, I'm not going to get this done, but luckily, sometimes it only needs to work once, and it's worked once today. So really happy, and I'm really happy that Sophie's worked, and I'm really happy that we've had loads of thumbs up with people working, whether it's the Tinkercad version with the virtual circuit, or when you plugged it in and it worked and it freaked you out because it actually moved. That's brilliant. Well done. So just a big congratulations to everyone who's participated in Glow Your Own this year. 6 weeks, not easy, but it's been a lot of fun, and it's been really great to meet so many people. We've got, just before we do go, I'm going to keep this in the recording. So we do have an event at Pegasus Theatre, and I'll put the link in the chat when I can find it. I sort of thought I had this ready, but I don't. But there we go. Here he is now. So I'm going to pop it in the chat there so you can see it. But it's part of the Oxford Light Festival. So if you put into any search engine, whether it's Chrome or Google or whatever it is. So at Pegasus Theatre, we're there on Saturday the 16th of November, and we're going to be there 10 till 4 p.m, so 10 a.m. in the morning until 4 p.m, and we'll be running this thing called the Glow Gallery, which is lots of lights and glow-in-the-dark things. But I'm going to be there, and I'm going to bring a few of these boxes, and we'll have some spare bits of LEDs and wires and things. So if you're missing something or if something's not working, please do come along, and I'll do my best to help you there and then while we're running this event. But it might be quite busy, so you might have to be patient. But what we do want to see is all your wonderful creations. It's great to see them. So keep on coding, keep on building, and well done for becoming a robotics engineer in 6 short weeks.
Well done, everybody.
So, and we'll see you hopefully next year. So from Sarah, Sophie, and me, thanks so much. And unmute Sarah so we can get Sarah to say goodbye to.
Bye, everybody. Well done. It's been really fun helping you all with your problems, because it's great to see them all getting fixed. It's amazing. Well done.
Fantastic. All right. And then we'll stay behind for the troubleshooting. But this is it from us. Bye.
Bye.
Yay, it works.
Yay. Fantastic. Stop recording.
Great job, everyone.
Well done. Gosh, it's